There we go. Can you see that one?
Yes.
All right. All right. So we're going to try this again. All right. Here is the first slide talking about what's coming. So, all right. And you see those, Cedric? We're good?
We're good.
All right. Wonderful. All right. So, this is, as Cedric was saying, this is part of a 3-week series. So we are in the second week for connecting Kubernetes and Apache Cassandra. So welcome to this particular one. And then next week, we will be taking application to the cloud by taking the application, deploying it up in GKE and Google along with Cassandra. So we're going to go to the next level. And as far as the housekeeping that we've been trying to do now for the last 5 minutes, so if you, yeah, that was really strange what happened there. So if you take a look over at the top left-hand corner, the first thing is our YouTube channel. Now, most of you who are watching us today are probably watching us there at DataStax Devs. So if you're curious about how to get to future content, anything like that, then keep an eye there. Go subscribe. If you ring the bell in the channel, then you will be notified anytime we have our upcoming workshops. And we do multiple a week, right? We have multiple things going on at any given time. Over on the bottom left-hand side, you will see the bit.ly link to Cassandra-Workshop. That brings you to our Discord channel. So for those of you who are with us on YouTube today, we're monitoring that channel. We will interact with you there. But just know that once we stop the stream, that stops, right? So you won't be able to talk to us anymore there. That's where the Discord really comes in. So it's really good to get to the Discord channel. That way the conversations persist. You get to become part of a community. It's like 7,000 strong right now of Cassandra folks. So we really do encourage you to go to the Discord channel. And that way too, if you ever have questions later on, you can totally talk to us there. You can't do that on YouTube. Up on the top right-hand side, we have the runtime. Cedric, you want to talk to that, what we're going to do with the demo piece today?
Yeah, so sure. Today it will be mostly me doing a demo because there is a fair amount of software to install to make the Kubernetes cluster working. But after the session, if you want to do the demo on your own, all the instructions are available on GitHub. The link is in the description below. Or we can spawn a cloud instance for you if you send an email to Jack Fryer or Alex Voloshev. Those emails were part of the invite today, and Alex will also provide his email on the YouTube chat. And with the cloud instance, you will have most things already installed, but we do not want to spawn 1,000 instance for nothing. So today it would be gently me doing a demo, explaining things, you asking questions, and after the session you will have plenty of time to do the demo and download all the tools needed to do the demo.
And that's even another reason why we encourage you to go to our Discord channel and register there, because that way, if you're doing this homework or if you're doing the stuff after the fact and you've got questions, you can just hit us up on Discord and we can help you out. Let's get into the actual content here. All right, and Cedric, you'd mentioned this earlier about for those folks who want to request a cloud instance for some homework and such, to send an email to Alex.
Yes, I asked to send email to Alex. So this is the email to have an instance, but also on the GitHub repo link below. When you start doing the exercise, there is a link to request some instance. But asking for Alex is better. You will send the generate the instance based on how many requests do we have tonight, and send the instance for everyone. And those will be available for 24 hours because as we told you, there is a lot going on those instances, and it's like 2x extra large on AWS. So that's pretty big to make that working.
And something just to point out, I just noticed in the YouTube chat that Alex is having discussion with someone about Docker. So yeah, this material does take some knowledge in Docker, and Cedric's going to explain some of that as well. But as Alex is pointing out in the chat, we actually have a full series on Docker alone, and Alex has dropped some links there. I believe the playlist there. Yep, he just dropped the playlist in YouTube. If you wouldn't mind dropping that in Discord as well, Alex. It's a wonderful series that Alex did in our Monday learning series that actually steps through Docker and everything. So if you're new to Docker and you don't have much knowledge there, go check that out. I think that's really going to be worth your time. Thank you, Alex. Okay, and then we have our hackathon. This one's awesome.
Yes.
This is huge. Yeah, Cedric, what do you want on this one?
No. Yeah, so I think the link is also in the description below, but starting end of December, we organized a hackathon. We call it the DataStax Holiday Hackathon. It will end next week, end of next week. So you still have time to go there and register to build a cool app on top of Astra, the tool we used last week. And, you know, the first prize for this hackathon is $10,000.
Yeah.
Okay. $10,000.
Yeah.
That's a lot
grand.
of cash.
That's a lot
for the first prize. And you still have 1 week to enter, free to participate, build a small app or bigger app, you know, make your bigger chance to win, and, you know, fill all the boxes. And it's not only one prize, 10,000. There are dozens and dozens of smaller prizes, like who have the better documentation, who are the most innovating, who bring the more interesting ideas, what has the best code quality. All these small prizes are there as well. Each time $500. So
yeah,
this hackathon all about cash. So you still have time to register. The link is there also in the YouTube description. And yeah, please submit some code and for us to review. And
per the question, Ram Krishna, that I see over there on YouTube, can the hackathon be extended? No. The 18th is the deadline. However, if, you know, since we're getting closer and closer to the end of that, if you take a look and maybe you don't feel like you could do as grandiose a thing as maybe you wanted to do, well, take a look. You know, Cedric was just talking about there are all sorts of sub-prizers. Maybe there is still something you could submit and, in fact, you know, be able to catch one of those sub-prizes or something. Or maybe you never know. Maybe you knock something out of the park and you win that grand prize. So I would definitely take a look. But no, the hackathon cannot be extended. So that deadline is absolute. And Cedric, here's a question from Grish. Does this workshop help the Cassandra Ops certification? I wonder if they're talking about the admin certification.
Okay, yeah, we will discuss the certification in the end. But as of today, there are two certifications, the developer certification and the admin certification. Soon, beginning of March, we will launch the third certification, will be Cassandra in Kubernetes. So it will be mostly useful for this third certification. Okay, when we will give you voucher at the end of the 3-week series, you can still redeem the code to try the third certification available in March. So is it useful for admin? Yes and no. We will cover some topics that are part of the admin, like the repair, compaction. We can still discuss,
right?
But it's very focused on Kubernetes, which is not part of the admin certification yet.
All right, thank you, sir. All right, moving right along. Okay, so just jumping into some Cassandra reminders, right? And we definitely understand there are some folks that have varying levels of Cassandra here, whether there's no prior Cassandra knowledge, there's folks who've been using Cassandra for a while, but we like to start off with just a little bit of reminders of what it is. The first thing is Cassandra is a NoSQL distributed database, right? So what does that actually mean? Well, if you compare that to, say, like a relational database or other databases that generally they are a single instance, right? If I have Oracle or Postgres or MySQL, yes, you can have master-slave setup and replication that way, but generally it's going to be a single instance, a single machine or whatever that's going to power the database. In the case of something like Cassandra, it is built to be a distributed database, and that works by nodes, right? So you're going to have individual nodes that are going to power your Cassandra database. So in this particular case, you see just one node here. I could run Cassandra like this if I wanted to. That would kind of defeat the purpose of having a distributed database, but you could. But really what happens is you build up a set of nodes, right? And each one of these nodes will actually have Cassandra running on it and have its own capability. Now, each one node, as you saw the little text that shot up there in the top right-hand corner, generally, we're talking a capacity per node, about maybe 2 to 4 terabytes of data per node. Throughput It's a lot. We're talking like thousands of transactions a second per core, right? The reason why we put lots and not one particular hard number, it depends. It depends on the hardware. It depends on how each one of these nodes is set up. But generally speaking, right, we're talking thousands of transactions per second per core. Now, these nodes all communicate through a protocol called gossip, right? So this is how they understand, like, what are my peers doing? Is a node up or is it down? Did a new node come into my cluster, right? This is how they communicate. And Cassandra is by nature a peer-to-peer system. So as you add and remove nodes, the system will actually automatically respond to this, right? You just configure them in and it'll automatically handle the addition or the removal, or again, if things are up and down, and that is happening over gossip. Now, when you combine a set of nodes, right, like what we see here, this is called a data center or a ring. So most of the time when you're working with Cassandra, you're going to be working with it at, you've got the cluster itself, but the cluster has a set of data centers that are in it, but you're going to work with, let's say, a particular data center. So this ring that you see here comprises my database, right? I've one entry point. If I were like making requests in and out, I can actually make requests in and out to any particular node here, right? And then those requests they'll actually automatically be replicated to the other nodes that are relevant and such. But really what I want you to take away here is that circle that you see, that ring, that is my database, regardless if the underlying nodes are distributed or not. Now then, how is data distributed around? We get this question a lot, right? I've seen so many times the question come through, well, wait, if I then put some data in one node, does that just go to all my nodes? Or, how does it know which nodes to go to and everything like that?
Exactly.
So what happens is in Cassandra, data is partitioned up by something, well, they're called partitions, right? So in any particular table, I'm going to have partitions. How do I partition the data? Well, when you create your tables, you're going to set something called a partition key, right? So if you notice in real small text there in the lower right-hand corner, if you look at that table to the right, you see we have country, city, and population. Notice at the very bottom of country, it says partition key. All we're saying here is we've decided for this table, we're going to partition by country, right? So what does that mean? Well, as data is coming into the system, as data is being written in, that data is automatically going to be distributed around my nodes based off of what partitions the data is in. And you'll notice that data that has like partitions are being stored in the same place. Now, to be clear, this is a very simplistic view. This is what I would call a replication factor of 1. I'm only making one copy of any particular partition. So something we can get into, right? Usually in Cassandra, your default standard would be more like a replication factor of 3. I'll make 3 copies. And that has everything to do with robustness. That way I can actually lose multiple nodes. I still have my data. It has to do with performance because now I have multiple nodes that can facilitate that data. That's getting a little further than where we need to be right now. What's important to understand is that, again, as data is coming in, that data is automatically being distributed around my cluster per its partition. So if you look at the top there, you see I have 2 rows of data for the USA partition. And if I move to the right, I have 2 rows of data for the France partition, so on and so forth. All right, before I move on, I saw some questions come through. Let me take a look at what these are. Okay. It looks like they got answered and they weren't anything technical or anything like that. Wonderful.
Yeah. But,
I saw them kicking off in my peripheral vision and I was like, I think I need to answer something. Okay.
Yeah, no. But even with the slide before, you immediately understood that select star from a table is a very bad idea. Let's imagine you do have 1,000 nodes.
Yes.
Select star from the table will take you minutes.
Yes. Yeah. Imagine that, right? To Cedric's point, that if you had 1,000 nodes, or if you have I like to always use the petabyte thing because Cassandra is totally a petabyte database. Imagine you've got that much data in there and you do a select star with no filters at all, nothing in your where clause. You're literally going and grabbing the data from all the partitions and all those nodes across your cluster, right? So that's generally considered an anti-pattern in Cassandra. Okay, so now if you look at how Cassandra replicates data, this to me is actually one of the coolest features of Cassandra. So Cassandra has inherent replication. When you create your key space, which by the way is equivalent to like a database or a schema in a relational database. When you create your key space, the thing that holds your tables, one of the things you also do is you set your replication. all the replication says is, how many data centers do I have? It could be one or more. And then, what's my replication factor? The standard is 3. So once I've done that one thing, then my data replication throughout all of my cluster and my data centers is automatically handled. So what does that mean? If you take a look at the left-hand side where it says geographic distribution, see there I have 3 rings that are connected by those arrows, right? Those are 3 different data centers. But again, those are all in a single cluster. So that one cluster is actually my database. If I were to say write some data over there on the West Coast to any one of those nodes, that data would automatically be replicated over to all the other data centers, and say my users over in India or in China would be able to get that data at the speed of wire, right? So as long as it takes that data to go with the speed of wire to get from the initial node over to the other nodes, they now have that data available. There's no ETL, there's no manual file copies or anything. The data is being automatically replicated, and that is being handled from that one thing you do when you create your key space. So it's awesome because it's so simple, and Cassandra just handles all of the hard work for you. And that's on reads or writes, right? So again, if I write some data to any node that you see there, those little blue nodes that you see there, then any other node will be able to see that data. Right. And then, of course, if I go to read data, regardless of where it was written, then I can just read that right away as well. Now, on the right hand side, where you see hybrid cloud and multi-cloud, this is another kind of key thing about Cassandra. Cassandra is deployment agnostic. It doesn't care where you put it. Right. So you can install it on-prem, you can put it in a cloud provider, you can put it on a mix of on-prem and cloud providers, what we call hybrid or multi-cloud, depending on the setup. So if I had on-premise and Google Cloud, that would be like hybrid. But if I had Google Cloud, Azure, AWS, that's multi. And I can do that interchangeably, right? You might also ask, well, why would I do that? Maybe I need to burst up. Maybe I have an on-premise installation, but it's Black Friday events, right, or something like that, and I need to burst up for a period of time and then come back down, and I don't want to have to physically procure all of that on-prem hardware. That's a great use for being able to burst up into, say, Google Cloud or AWS or something like that, right, and then go back down. Or maybe there's some capability, like I want to leverage some of the machine learning capabilities that's on one of the cloud providers that doesn't exist on the others, right? I can easily just add a data center, update my replication to replicate that data center. Now that data is available there on that system. We've even seen cases where folks will do it just pure out of leveraging, being able to have leverage power with the major cloud providers. Because if I can very easily, say, move to Azure over Google Cloud or something like that, and I can do it at the flip of a switch, then it gives me leverage power. Or maybe I'm hedging against potential failures. The cloud is a wonderful resource, but if you've watched in the last, 3 years, I think every single one of these major cloud providers have had major outages at some point. So we've seen a lot of cases where folks will actually spread their cluster over multiple cloud providers as a way to protect them in case there's a major outage in one, they can just easily move over to the other one. So this opens up all sorts of possibilities. And again, this is all powered by that inherent replication that is set literally when you set the replication in your key space. All right, Cedric, I don't know if there's anything you wanted to add to that. I saw a set of questions come through that I was going to take a look at here.
No, I think you made it right. One single technology, and you can have a database crossing multiple clouds and multiple regions. You don't have to worry about any replication. So, if you're working on a mobile app, people can have the data pretty close to them, reduce latencies, and you don't have to worry. The same things you may do with your code using CDN in the Jamstack in JavaScript world to make the code close to the user. We can do the same with the data using Cassandra technology.
Yeah, and it looks like Alex is all over the questions here on YouTube. I think he's answered all
Alex
of them that I see. Yeah, he's on fire today. I'm pretty darn sure he has. Yep, I think Alex answered them all. So wonderful, Alex. Thank you so much for that. All right, great. All right, so just moving on a little bit. So if you look at some of the use cases, right, that are available for Cassandra, scalability is definitely one of the big ones. Cassandra is known, it was purpose-built to be able to horizontally scale indefinitely, right? So if you compare that to like vertically scaling, where with like, and by the way, I'm going to reference some of the relational DBs. I'm not trying to knock on them at all. It's a different tool for a different need. Relational databases were born in a totally different era. They are general purpose databases, and you can vertically scale them, right? You can add more CPU and add faster disk and add more RAM. But as we like to joke in the Oracle world, you can scale up until you run out of money, right? At some point you hit a ceiling and you just can't get there anymore. Where Cassandra was built to be able to horizontally scale out on commodity hardware, right? So scalability is definitely one of the strong use cases here. So what this translates into are, let's say you're doing event streaming or IoT, Internet of Things, right? Sensor networks is a great one. We see a lot of Cassandra usage for things like various sensors, whether those are weather sensors or whatever. Imagine the amount of data you have coming in from all these different sensors that are all over the place. Cassandra makes a really good system for this. And what's cool, again, as your throughput needs increase, you can just increase the size of your cluster and then handle that increased throughput. Availability is another big one for Cassandra. So Cassandra was built originally, when it was first built like over 10 years ago now, to be able to handle failures well and gracefully when they happen, because they are guaranteed to happen. As a matter of fact, if you look at any distributed system out there, as you increase the number of nodes, right, you increase the number of potential failures. Not just Cassandra, that's any system at all. So Cassandra was built, and there are a ton of like robustness and like defense mechanisms that were built in to handle what happens if a node goes down, what happens if the network is severed, all sorts of things. So if you have a case where you've got like a mission critical app, you need to ensure that your database is always available. That's a really good fit for Cassandra. As a matter of fact, from the always on, it's called the always on database, right? The reason why is because Cassandra is built in such a way that in some configurations, you could lose 2/3 of your capability and still have an available database, right? Still be able to facilitate reads and writes and requests and everything. And it's amazing. We're not doing it today, but it's really fun for those of you who've played with multi-data center setups. If you're replicating the multi-data centers, and you can very clearly see cases, you could just take down a whole data center and your other data center is there and it can still facilitate that stuff. So it's really good for those types of use cases. Of course, for distributed, I see some of the questions that Alex is already on top of in YouTube, talking about the distributed nature of things. And from the one graphic we showed a minute ago, that geographic one, you could totally have a global database with multiple data centers in different places in the world. Where this really comes into play is, imagine today, just by de facto standard, almost all of us, we have to create global apps. Why? Because our users aren't just in one data center in the US or something like that, right? They're in China, they're in Australia, they're in the EMEA, whatever, they're all over the place. And there's too much latency. If I have one database and a data center over here in the US, then my users over on the other side of the world are going to incur way too much latency in the response times and such. So what do you do with this? Well, you put data centers out in those different places, you put the data where they are, and again, you use Cassandra's inherent replication to push that data around for you. And where this really comes into play is you see there in the middle that compliance or GDPR. That's a really good example of something where I might have a data center in the US that doesn't need to worry about GDPR, but in EMEA I sure do, right? So I can have multiple data centers there, and then I can have different security configs on each and such. So it really opens up a lot of possibilities there. And especially for the customer experience you see on the very right-hand side, again, putting the data close to where the actual users are so they get what they feel is that instantaneous response and not the huge response and lag times from having to go latency over wire across the world. And then finally, with the cloud native piece, it's just a good fit, right? The fact that Cassandra itself is cloud agnostic, you can put it in any cloud provider. You're not locked into a particular vendor or anything like that. It automatically allows that flexibility where you can deploy in multiple configurations across cloud providers, or even with a single one in your on-prem install. All right, let me take a look at the content or questions. Okay, we're good. All right, so just a couple things in vocabulary. So we've kind of talked about this a little bit already. So at the outer edge there, you see the cluster. That's essentially, this is your database, right? That's the cluster level. Within the cluster, you're going to have your data centers. And then within your data centers, you have nodes, which we've already talked about, and racks. Racks are subsets of nodes within a data center, right? Those come into some more special use cases, but they are there to kind of offer up even more kind of options in the ways that you're handling replication and such. We're not really going to get into that today. What's really more important is just to understand cluster is your database, the data centers, right, are the individual rings of nodes, if you will, and then you have the nodes within them. All right, with that, that's our primer on Cassandra. Just to get there, I'm checking out the questions, and I see that Alex, again, has been all over them. So I think we're good. You good to go on here, Cedric?
Yes, sure. So this time, let me try to share my screen again.
You want to try to share again?
Oh, right. No, let's keep like that.
Okay.
Enough the troubleshooting. You will move me through the slide.
Oops.
Okay, so that was it for the Cassandra part. The important thing is for you to understand that Cassandra is a distributed database. And so to deploy Cassandra, you will have multiple modules, multiple parts to deploy to make that work. It's a distributed system. All right, moving to containers. Okay, what we used to do in the past, and maybe some still using virtual machine. You want to have multiple operating system on the single machine. And the idea is always to do as much as possible with the same infrastructures. Okay, so virtual machines are pretty cool. It's a huge file with embedded an operating system where you can deploy your app, and that is pretty easy to copy, just to replicate the environment. It's as easy as replicating a file, right? And having a single hypervisor driving this virtual machine, now on a single physical server, you can have multiple virtual machines. This is the beauty of virtualization. But here, the issue immediately you might notice is look at the stack, how big it is. The issue is in each virtual machine, you do have the operating system, the big square in the middle. And you want to avoid having multiple, Windows or Linux running in the same machine because it's taking some CPU and resources and RAM. And if you could have a single operating system and having application running on top of them, that would be cool, right? And this is where containers came in place. So containers are simply Linux or Unix processes. That's very simple. It's based on LXC, but never mind. The idea here is really to have, now you do only have a single operating system. On top of it, you will have the blue rectangle here. It's called Docker engine, but this is kind of a container engine. It could be Docker, or it could be new containers engines like Containerd or Podman, which are more and more relevant solution. And in the Docker engine, then you will deploy instances. And instances are what we call containers. And it's pretty easy as well. It's easy to make scale, copy containers multiple times, replicated, scale out. And now with the engine from the container, you still have resource limitation, enough security to avoid the container to exchange some data or security information where they should not have these authorization levels. So it's all about doing more with the same physical infrastructure, and no doubt it has so much success. So next slide, please, David. So Docker is still the leading implementation of container engine, what we call a Docker engine. So inside a Docker engine, so Docker engine is the runtime with a Docker daemon. And using some Docker command line, you will interact with a CLI, command line interface, and send some command to the Docker engine, to the Docker daemon. So your Docker command line is simply a client sending some request to the engine. And the engine could be interfaces with a REST API. It's all based on a REST API. So simply put, no more than that, you type command and you send command through the REST API to Docker Engine, and Docker Engine will start or stop or interact with running containers. Okay, next slide. So what is the life cycle? Well, I saw just in the question in the beginning that some of you are not really familiar with Docker. So again, some vocabulary. So when you do have your app and you are pretty happy with the code and the tools you need to run your app, you will create a snapshot, a photo of your environment, and you will create what we call a Docker image. To do so, you are using what we call a Docker file, which is a set of instructions, a recipe, where you say, okay, I will start with a Linux, then I will install, I don't know, Python, because I need Python to make my app run. Then I will copy paste my code inside this box, and I will add a command line to start my app. And with that, I'm happy with my image, and I will ask Docker build. Docker build will run this recipe to create you an image. Once the image is immutable, it won't change. If you are a developer and working with object-related programming language, the image is like the class, okay? Something static that won't change, and it's just there as a template. This image, you can push this image to a registry, so a repository where everybody else can use the same image, or you can pull, so you will download the image locally, just to be able to start, some environment based on this image. So when you execute Docker run, you will use that image to create a container. So a container is like an instance. Okay, now I think you saw images, and which are templates, and containers that you will start based on that image. Okay, and now you got the client, the host, and the registry where we will store all the Docker images. But again, this is short form introduction to Docker, just for you to get the keyword like image and containers. But on this channel, we do have, I think, 4 weeks, so it's 8 hours on Docker. So
it was 4 weeks, 4 weeks worth. Yeah, Alex dropped it earlier. And Alex, if you wouldn't mind, if you've got the link handy, to drop that one again to your Docker series, that'd be really useful. And for those of you who haven't used Docker before, from a development standpoint, Docker is actually pretty awesome. It will allow you to spin up. As a matter of fact, Cassandra's on Docker is an example. Instead of installing it fully on your own and having to go and configure all your paths and all that kind of stuff, you can just spin up a Docker container in minutes, right? And there are so many different applications and services that are available through Docker. So if you haven't checked it out, I think it's a good idea.
Exactly. You don't want to install the tools anymore on your machine.
You don't need to anymore.
You simply just Docker run,
Yeah.
And it will download the image and you can start working right away. And the beauty of an image is everything is prepackaged and ready to start. You don't have to struggle about starting command or anything. Okay, next slide. So this is our images that we could use to create containers. So Cassandra is no exception. The Cassandra developer teams created a Cassandra Docker image and push that Docker image to what we call the Docker registry or Docker hub. So hub.docker.io, and there you will see the public images to everyone. So if you simply say, like the command you see here, Docker run Cassandra, it will pull the image, so it will download Cassandra, and it will start Cassandra like that. And now you might realize, okay, but now I want to provide some configuration to this image, and this image is static, it's a template, so how it works. So in the Docker run command, we will we will use a set of parameters to explain Docker how to run this image. So you do have -- name, just provide a name for the container. But hey, you cannot have two containers running with the same name. So yeah, that's just not something you use very often on production. You will let Docker pick a random name because you don't care about the name. -d telling you, okay, run that as a daemon. I don't care. I don't want to get the command line in this container. Just run that on the backend. -e for environment variables. Okay, so here key equals value. And so here is one key available in the Cassandra configuration. But if you go to the Docker official image on Hub, you see dozens and dozens of keys you can provide to override the default configuration of Cassandra. -p is for port. Which port do you want to open? By default, the containers running is you cannot reach this container. Everything is just locked. It's for security reason. So if you say -p 7000, 7000, now when you are running this container on your host and you go to localhost 7000, then you will rely on 7000 in the container, and so you can access services in container. So 3000 for Node, 8080 for Java most of the time. So 7000 is for intercommunication in Cassandra nodes, and 9042 is for a driver to connect to Cassandra. This is exactly what we did last week. And -v is for volume. I didn't tell you, but when you start a container, it's a stateless object. And so if you kill that container, it's done. Nothing remaining. So for a database is not really what you want, right? So you want to mount some volume, so some disk you do have on the host that you will mount to the running container. And now if you stop or kill the container, the data is still available on disk. And when you restart your container, the data will bring back to your container. So first important things here is to work with stateful application. So applications that do have a state that need to save data. And if you stop and restart, you want your data back. In Docker, you will use what we call volumes. All right. So you might say, okay, that Docker command is already pretty long. Now, if I add, I don't know, 10 volumes and 20 environment variables, it's just a nightmare, right? It will be a command so long, it's hard to maintain, hard to work with. So Docker provide, on top of the default Docker CLI, Docker Compose. So David, if you move to next slide. Now, in Docker Compose, you can have a YAML file where you will define, oh, I would like to run this container, for instance, Cassandra seed here in green. Use the image Cassandra 3.11.6. So, okay, this is the template you should use. Provide a container name if you want to. Do the port mapping, environment variable exposition, and volume mounting, okay? But now you can define everything as a YAML. And also you can introduce some dependencies between containers. In Cassandra, there are different flavors of nodes. One node is used as a seed, and when you want to make your Cassandra ring scale out, you need to provide the seed IP. So this is how you do that with Docker Compose. And using this file, you will start two node cluster. One is a seed, one is a node. But, you know, even with that, you say, okay, you can introduce some dependency between the node, but what happens if one node fails? How do I recover? Or how do I make one node scale. If I want 2 instances of Cassandra node, how do you do? Well, that's technically possible by doing docker compose -- scale Cassandra node equals 2, as provided on the top left-hand corner. But what about the disk? How do you tell that guy that the second node should not use the same folder to save data? It's not easy. It's really not easy. So Docker Compose is super cool to work on development, to run multiple containers in your laptop and make those containers talk to each other. But if you go to next slide, David, you might say that, okay, for Cassandra, this Docker Compose seems to be pretty appealing. Cassandra in Docker, okay? Use the Docker image from Cassandra, provide the proper parameter, you're good to go. But the reality is, if you click next, it's simply not enough. Because you cannot handle all the situation. If one node goes down, how to restart the node? If you need to scale out, or there are multiple situations where Docker Compose cannot orchestrate the containers. All right, so moving on, what we need then is a container orchestrator. And the container orchestrator, no surprise, will be Kubernetes. So if you go to next slide, so definition for Kubernetes, if you go to the kubernetes.io, is Kubernetes is an open source system for automating deployment, scaling, management of containerized application. With Docker Compose, you can define some dependencies between the container, but it's not enough. You really want to introduce some management. Okay, how much time do I make my containers number 2 wait, just to be sure that container 1 has been properly started and is ready to get my requested. So introduce more advanced dependencies between the containers. And if one container goes down, it's all about Kubernetes. So if you go to next slide, you see a landscapes of features provided by Kubernetes. We already told about horizontal scaling. I want these container to scale as much as needed. But hey, now I don't know, you do have your microservice scale out and available 3 times. How do you do load balancing between your 3 instances of your service now? How do you do that? Well, Kubernetes provides you already the load balancing, and now you can give to your clients only a load balance URL. And if you need to scale out and add multiple instances of your app, clients don't care, they simply use the load balancing URL. If a node goes down, if your application goes down, Kubernetes will automatically detect that this container is down, and it will retry and restart the containers for you. I use a lot the word containers on purpose. We just came from Docker explaining, but Kubernetes has its own vocabulary. So let's see what it is, because we do have the vocabulary for Cassandra. Let's discuss the vocabulary for Kubernetes and make those 2 words match. Okay, guess what? Kubernetes is a distributed system as well. But unless Cassandra, there is a master. Okay, and this master is called the Kubernetes control plane. And in a Kubernetes cluster, you do have a master that can be replicated for resilience reason, and multiple nodes, what also we call multiple workers, multiple slaves. And so when you interact with Kubernetes, like Docker, you will use a CLI. So instead of Docker run, you will do kubectl for Kubernetes command, kubectl, provide a command, and this command will be posted to the REST API part of the Kubernetes control plane. So when you set up Kubernetes on your machine, you will map your kubectl command with an existing running Kubernetes cluster. It's simple as that. All right. So if you open now, on next slide, if you now open the master I don't want to go too much into the detail, but here the master is the brain of the system. And so first, this guy should have some control manager, controller loop. I need to check all the pieces to see if everybody is healthy. And if it's not healthy, I detect that one container is down. Then I will talk to my buddy, the scheduler. This guy is one is down. Please create another one. Okay, the API server, I told you, this is the one getting the command. And there is some storage, some way to store the state of your system, and it's etcd. It's a key value database. Okay, so and I don't go too much into the detail for the master in Kubernetes. Let's see about the slave or the minion or the worker. So first, they do have a kube proxy. So this proxy help to interact with the master, just to get all the commands. With kubelet, which is an out-agent, but never mind. What is important here to know is in this worker, you will have multiple pods. Okay, those are in orange. So now we stop talking about containers based on image, remember? We talk about pods. Okay, the pod is the orange box over here. Inside a pod, you can have one to multiple containers. Okay, the one we just spoke together until now, Docker containers, containerd containers, podman containers. Well, in the pod, you can have one to multiple containers, not only one. And especially with tools that is not HTTP ready or do not expose any interface to interact with it, you want to provide another container inside the same pod just to help this guy expose to the outside what's happening. So I don't know, you do have an old technology only exposing GMX, old Java technology to expose metrics. And in Kubernetes, it's all about HTTP, web server. You would create what we call a sidecar, which is a running container. This guy will only, plug to GMX and expose HTTP interface. Well, okay, so inside a pod, multiple containers. And what you will scale with Kubernetes are pods. So you put in the same pod components, containers that need to scale together and work tightly one to each other. Okay, so it's a lot of words, it's a lot of vocabulary, but hey, at the same time, we just give you only the vocabulary needed to understand what's coming in how to deploy Cassandra in Kubernetes. So after these infrastructures and all the architecture of a Kubernetes cluster, let's dig into what you actually create in Kubernetes. So pod is one thing, but it's not the only thing you create in Kubernetes. Everything you create in Kubernetes is called a resource. And what I will show you that there are multiple flavors of resources. First is what we call a namespace. And as the name stated, it's a way to isolate a bunch of resources components inside the same name. So the best practice is if you build an application that needs multiple pods, you tend to put them in the same namespace. And like that, you can interact with them, providing the namespace and do some group operation, for instance. And if you don't need your app anymore, you can totally drop the namespace, and all the pods related to this namespace will be dropped as well. So you might notice that these namespaces are really logical. If I create a namespace, it will live on all the worker, all the slave, all the minion. Okay, it's really now everything that we create as a resource will be available, and you don't need to care about which worker does I'm working on. Okay, namespace is one thing. What do we have next? I'm going one resources after the others. Do we have any question that Alex is not able to keep up?
So far, he's keeping up, but there was one here from Dina Haran in YouTube. Is it possible to build a Cassandra cluster to spread across multiple Kubernetes clusters?
It's not an easy one. Actually, no, as of today, and very few stateful applications will be able to work across multiple Kubernetes clusters because you need to federate those clusters. And technologies to federate those clusters are not mature yet. Okay, some are just released last year. I didn't see any article that it's production ready. So I would say be careful. You need to have a center brain. You can have the same Kubernetes cluster running in multiple locations, having workers in multiple locations, but it still needs to be part of a single Kubernetes cluster, as far as I know.
Yeah, as a matter of fact, Alex is making comment here about that. Yeah, Alex just said it in YouTube. It's possible without the Cass operator. So it sounds like there is a configuration point there. I don't know how much work that entails. Maybe Alex can give us some insight into that. If we're talking about outside of the Cass operator and using expanding across multiple Kubernetes clusters. We'll wait for it though. I'll see if he says something. And I'll let you know.
But you might see, you might tell it's a peer-to-peer communication, and you don't have a brain that will tell you I need to spawn nodes here or here. But anyway, moving on. So about a pod, about the namespace. So you do have your stateless application, like your microservice, no database, nothing. Just simply start a bunch of pod and you're good to go. But what if you do have state? You need to save the data. As for Docker with volumes, well, on Kubernetes, those are called persistent volume. Okay, so persistent volume are mounts or associated with pods, just for the pod to be able to access these persistent volume. With persistent volume claim, which is just access controls list for you to access the volume. What kind of volume? Well, which is pretty cool with Kubernetes, it's declarative. You can define, I do have some disk with SSD very fast, and I will create something called a storage class, telling that, okay, this storage class is disk for Cassandra. It will be 1 terabyte large and use SSD technology. You want big enough using SSD to be as fast as possible. But for others components inside the same Kubernetes cluster, you need some low speed disk mechanical drives, and so you can have another storage class. So when you start something that needs to be stateful with a state, with data storage, it's all about data on Kubernetes, you will define volume, persistent volume, and when you do that, you will tell which storage class you want to use.
And something I just want to add here, I think this is actually one of the coolest features, especially when using the Cass operator, which we're going to get to right with Kubernetes, is that with persistent volumes within Kubernetes, you could lose the pod that contains your Cassandra instance and just spin up another one and it's in a place. And it can just continue on from where you were before, like almost nothing happened, because you have that persistent volume and the data for your database, the node is still there, right? I think that's really powerful because, I mean, when you're doing updates or if for some reason you lose a pod or something like that, then it just heals itself, right? So I've always thought that was a really cool feature of this whole setup.
Yes, and this is a strength of Cassandra. The data is available on multiple nodes, and if you lose any of the node, it's not a big deal. Service is still available,
and Cedric,
and you will. Yeah.
Oh, I'm sorry. No, go ahead and continue. Sorry.
No. Go for it. No.
Sorry, there's a question from Satya in YouTube saying, should we be using static PV or dynamic PVC is fine?
That's a very good question.
Yeah.
And I will come to that just at the slide after that. Because as of today, in the way we propose to deploy Cassandra and Kubernetes, we are using stateful set. So I think, David, you can move to next slide. I think STS is just the next slide. Maybe not this one. Next.
There you go.
See. Okay, stateful set. So a stateful set is simply a way to say, oh, remember my pod and the disk needed for this pod? I will create a stateful set just to map the two of us together. And so when you create a Cassandra data center, you may have multiple nodes, and so you may start multiple pods, and each time you add some persistent volume. The way it is coded as of now, it's a dynamic PV. It's provided when you initiate the stateful state. And as the persistent volume is considered to be close to the pod, if you lose the pod, you can consider the disk as well lost, because it is a way to work with Cassandra. If you lose a node, okay, that's not a big deal. Service is still there. And if you're not able to restore the losing node, you can simply add a new node to the Cassandra cluster, and the data will be reshuffled among all the nodes. And so because Cassandra ad hoc provide these features of redistributing the data, we are using ephemeral storage and dynamic persistent volume. But that's for today. I mean, during this year, later, we are working on, we try to partner with providers like Data and OBS just to do some static persistent volume, preempt some disk just to be able to recover and do not let Cassandra do his reshuffling and maybe gain sometimes if a node goes down and you want to restart this node very quickly. So as of now, ephemeral, dynamic, but more coming soon.
So here's a really neat question. I think you're going to like this one, Cedric, by None. Actual user none. Just go for null or empty, right? But if pod goes down and new pod kicks in, hinted handoff and gossip still happens, I suppose?
The new node would have a new IP, probably a new IP, so it will be considered a new pod, so it will bootstrap, and we will reshuffle the nodes. Because IP are allocated dynamically, I don't think the intent handoff will be there if you totally, shut down the node. But if the node comes online, for network issue, something like that, so the node is still living, but you cannot contact him. When the network come back, the gossiping is still there, and it will reconciliate, and the intent handoff will happen. But with pod and Kubernetes, it's logic like, oh, it's not working, I kill it. Sometimes we just use the association pet versus cattle. So pets, you give him a name, you cherish your pet, you love your pet. Cattle, you don't care. You're just giving numbers, and if it dies, it dies. You just create a new one. And so it's the same logic. So if really the pod is not healthy, you will kill it, create another one. If it was a matter of network issue, it will come back and it will simply do the intent handoff and reconcile.
And I've got one more here for you from Panagoyas. Says, is it possible to resize the Cassandra storage of a node after deployment? Thinking about it myself. That's a good one.
Yeah.
I wonder if you could change the size and then just apply the configuration, right? I wouldn't reduce it because
no. You want to expand. Use a new storage class, bigger storage class.
That's right.
You know what? I would back up, create a new one bigger, and restore. I'm not sure you can edit a storage class at runtime. because what we will do, you will edit your Kubernetes YAML with the new storage class, bigger. Then you will reapply your settings. It will spawn new PV persistent volume with the larger site. What do you do then? You need some extra tools like Medusa to do the restore of your node, or it will be considered as a new node and start doing all the data reshuffling. But I also count on Alex on the YouTube somewhere just to confirm that behavior. But we could take that question.
Well, and Dinah Huron over on YouTube is saying the most recent version of Kubernetes allows resizing your PVC. But yeah, and Panaglotis is saying that they'll look it up. So cool. All right, thank you.
Cool. I didn't say any stupid things. Cool.
Right.
Yeah. Okay. Yeah. I still have some credits. Let's move on. If I say something stupid, now everything's fall apart. And,
that's funny.
This guy just moving head on the screen. Okay. So have the term for Cassandra. What is a cluster rack node? And you do have the same for Kubernetes. So our mission is to make that distributed system fit into Kubernetes as is. So what you would do, just thinking what you would do to do that. Okay, we might know that a node could be a pod. I need some persistent volume to mount some data. I probably need some configuration I could share with multiple pod, open the network, maybe provide some secrets to have username, password, stuff like that, and you'll be good to go, right? Well, not really. And if you move to next slide, David, this is the small stuff I put in place. In Cassandra, there are some rules to administrate cluster. Those are part of the administration cluster. And for instance, there is the 2-minute rules. You should not add multiple nodes inside a Cassandra cluster at the same time. The proper way to do it is really I create my first node, I wait the 2 minutes until this node is LC and I join the cluster, and only then I create a new one. And there's really one rule among dozens and dozens of rules. And so the default resources in Kubernetes are not enough to handle distributed Cassandra. You still have the rules to apply, and how do we react with some nodes goes down or a node becomes unstable. You do have multiple procedures to recover, and you need to execute some command and see what's working, what's not, and based on that, act on your cluster. You also need to schedule some command to backup, to restore, to do the maintenance, what we call repair or compaction of your table if you need to. So only with this pod, persistent volume, and all the default resource I gave you, it's not enough. And unfortunately, it's not enough. So what can we do? Well, moving on, we do have the solution for you. So if the existing definition in Kubernetes does not fit your needs, you can create new one. This is what we call custom resources definition. And so that's kind of the template. And when you instance that, it will be a custom resources or custom resource definition or CRD. And then there is in the YAML, so if you're not aware, Kubernetes is simply a notion of YAML, okay? Kubernetes is YAML as a service, okay? It's all about YAML. Well, so you define your own resources, and there is a part of the code which is spec for specification, where you will define some keys and dedicated configurations. Okay, and so you want to do some cron tab here as a sample. You define your own configuration, default values, properties. And those resources, like every resources on Kubernetes cluster, have a state. Okay, so let's say I have defined what look like my resources, provide some state, some properties. What do I do with that? How do I tell my, remember, little scheduler and control loop controller knows, okay, how do I behave with this new guy, which is totally exotic? You need some component in between the Kubernetes master and this resource to know how it behaves. And to do so, we use what we call an operator. If you move to the next slide, you will see that operator is simply a type of component of resources inside Kubernetes world that just here to help the default controller to listen and to change the state of a CRD, custom resource definition. Okay, and so this guy will listen all the events coming from the CRD, will send event to this just to act on it, execute some command, and make it work. And so if you want to install an application that needs the operator, what do? First, you define what the operator look like, okay, the operator there. Then you instantiate this operator. It's a running process that needs to listen and send event and get event. Okay, so define the operator, start the operator, but with that, nothing happened. Third operation, you need to define your CRD and start a CRD. And now the magic happened. I start a CRD and the state is initializing. So I sent an event telling that I'm initializing, then the operator knows, okay, because you are initializing, the next step you need to do is do that. And step by step, the operator will give the workflow to start all the components in your app or the component you want to start. And so what we did at DataStax, we created a CRD matching a Cassandra data center or a ring. Remember the ring over here? We do a CRD for a ring. And so if we instantiate this CRD, what we want the operator to do is start the first node, which is the seed nodes. Remember the one that we want to start first. When the guy is online, move to the second one and third one, and so forth and so on, until I do have my data center running with the proper number of Cassandra node I asked. And each time it will provide not only the pods and the disk for each node, but also some extra resources like secret, login, password, configuration. Remember the -E with all the settings you provide on Docker? Here, now you do have a dedicated resources called config map in the Kubernetes world that will be used and inject in the running container to provide the settings in all the running pods. And that's as easy as it is. You may have read tons of documentation around Kubernetes. Operator is just that. It's a new guy listening all the events and act on simply the CRDs has been defined for. All right, moving on. So our Cass operator, so that we open source, so created by DataStax, but not only member of the community work on the operator. There are still multiple operators on the open source to interact with Cassandra. This is the one, Cass operator is the one proposed by DataStax to the community. This guy can do some ring initialization, the data center or ring, as I told you. Seed management, I told you start with the seed and add new nodes based on that. Do the rack management. So in the Cassandra vocabulary, you may have remember about the rack. This is just an insight to tell Cassandra, oh, by the way, those two nodes will use the same disk or will use the same IT resources. So they should we just tell them this is part of the same rack. And when Cassandra detects that two nodes are part of the same rack, they tend to distribute the data not at the same two nodes, because you just increase the risk of losing the data. If two nodes rely on the same disk, you tell that to Cassandra, and Cassandra still write the two replica of the same data on these two nodes, you do have a risk that if you do lose the disk, you will lose the two replica of your data at the same time. So you want to avoid that. So Cass operator is aware of rack and will create some stateful set per rack. All the settings for your ring or data center will be in the Cassandra data center resource definition, CRD. And here it comes the magic. If you lose a node, it will try to reboot, and it will, if you need to expand your cluster, you will simply go to the YAML for your CRD, and you will change number of nodes for X to Y, and then apply this new config, and the operator will spawn new nodes one after the other and do the scale up if you want to. Also, if you do have some settings to change, remember, you do have 1,000 nodes in your data center, and for some reason you decided that now your memory on the JVM should be moved to 500 megabytes to 700 megabytes. Well, by simply changing one YAML file, the operator will start and changing the config for every nodes one after the other, and do some rolling restart for you. So that's also pretty cool for rolling a new config. Or if you want to upgrade Cassandra version, why not? Boom, this guy will start running the nodes and make that work for you.
Yeah, and I also want to jump in here too. That scale up capability to just change the YAML and apply it, right? That's another one. If you think about it, for anyone here who's actually ever managed their own Cassandra clusters before, and you've added a node, right? It's not too bad. Once you get used to the pattern, it's actually quite easy. But the Cass operator in Kubernetes, in my opinion, makes it even easier, because then once you have your cluster running with the Cass operator, as Cedric just said, if you want to scale that thing up or scale it back, all you have to do is change the YAML and reapply it, right? It handles all of the rest of it for you, all the base configuration and everything. So it's like, again, one of those like really cool features that once you get to start to play with it and see how it works, you're like, oh, that's nice, right? That kind of reduces some of the administration overhead.
Exactly. Yeah. And so we talked previously about multiple Kubernetes cluster, which was a bit wild. But here, with the Cass operator, you can have multiple DC. Okay. You can create multiple CRD, part of the same cluster, simply provide the same cluster name, and when the node will be spawned, they will join the same Cassandra cluster, which is pretty neat, right? And so if you do have some migration on a new DC to create, Cass operator is enabled for that as well.
So I do have a question from our friend Dana Haran, and this time Discord. Switch over to Discord. Hello. Where can I find more information about the Cass operator? I do know that there's a repo out there. Oh, and boom, yes. Alex dropped it. Alex dropped it right when I said that.
Probably github.com/datastax/Cass operator.
That's the one. Yeah, that's totally
exactly
one.
Something like that. We tend to open source what we do. Also, okay, let's do like that. So here is just a sample definition of a Cassandra data center. So our CRD. So here you can see, let's look at the right part of the settings. You will define your cluster name, server type, server version. So the Cass operator can work with Cassandra 3.x, Cassandra 4.x, DataStax Enterprise, the enterprise distribution of provided by DataStax, with Cassandra at the core, but also providing Spark, Graph, and Solar to do some search. So it works both with OSS and DataStax Enterprise. Here we define some data center with size 9, and you can spawn some rack. Okay, just I would like to create a rack based on the availability zone here in AWS. We are entering a little bit cloud settings. We will do more deep dive cloud focus next week to move all we are presenting today to the cloud. So this is a sample config telling you that, okay, now those nodes will be on the same availability zone in the same region, but different availability zone. And so when Cassandra will spawn some nodes and distributed data among these nodes, especially distributing the data, defining the token range, how to distribute the data, it will know that, oh, those two pods are part of the same availability zone. So if I can, I will not put the same data in those two, just to be as reliable as possible. What else do we have? Yeah, we do have the storage class, okay? Which kind of disk should we use? And we can also have some Cassandra config, which keys should I override when I start the Cassandra.
So Cedric, I've got a question here from Yurta in YouTube. Is it possible to have different versions of the operator within the same cluster? Say upgrade the versions only per namespace. That's,
I don't know.
I don't know either. I don't know. Alex, I wonder if Alex has a comment on that one.
We can reach out to the team. Just to see.
Alex gives a so he's thinking about it too. Yeah, we'll have to think about that one. Come back to you on that one, Yurta.
The operator itself had its own versioning, so you would have your instance of operator listening for some kind of events. And when we release a new version of the operator, this guy should be backward compatible, should increase and read new events. But we need to have validation from the engineering team here.
And Alex's second response was, I'd avoid the situation. And I kind of feel the same thing, right? Because you're adding an extra layer of complexity into your configuration at that point, and that could lead to some unintended consequences. But we'll have to see what the engineering team says on that one.
But at the same time, I'm understanding the question very well. Kubernetes is moving so fast. 1.5, 1.15, 1.16, 1.19. We do have a new Kubernetes version every month. Yeah. So at some point, you might consider, okay, how do I migrate my own Kubernetes? So should I use another master with the new version?
Right.
And you might ask the same question regarding operator and everything. So
yeah, it's a good question.
That deserves a proper question that we will probably put on community.datastax.com to have everybody get the answer writing down.
Yeah, and I'll go ahead and log that one to make sure we don't lose it. Okay, cool.
Yeah, prefer to say, I don't know. Okay, so boom. And you don't need to understand all things here. Again,
you'll be quizzed on this. Go.
Okay, yeah. Try to find the blue guy named PVC. Try to spot okay. Even with the single YAML definition, this is all the resources that are created for you. So not only the DC, but also some disk, pod, PV, PVC, super user. And now you can see here it's only a single node cluster, and this is everything that has been done for you. And if you make your cluster scale out, you will simply add new pods at the very right of the screen. The one named cluster1, DC1, default STS0. Adding new node will simply add new lines with new pods. We do have pods for each Cassandra node. We do have a stateful set for each Cassandra rack. We do have a dedicated custom resource definition for a data center or a ring. And the same operator can be used to manage multiple Cassandra clusters. Now you do have some mapping from Kubernetes to Cassandra. That should talk to operator, developer. For developer, it might be a bit not that easy, but it's a lot of info. I get that. But as usual, we provide all the resources. And when you will do the hands-on after this session, you will get the hands and you can be able to invoke kubectl to just list all the resources that have been created and interact with them to see all things work. Okay, all right. So now with the Cass operator, you're pretty confident to make your Cassandra cluster running. And if something goes wrong, you expect this operator to catch up and replace what needs to be replaced and handle all the failover for you. And if you need to use, in your app, just in interacting, you expect as well to have services, DNS, everything needed to be able to connect to all the nodes in a transparent manner. Okay, so let's move on. And here comes the big one. Okay, this one I will move fast. Remember where I told you in a single pod you can have multiple containers? I was really thinking about that. Cassandra is a Java application, pretty cool, but when it comes to interact with Kubernetes, yeah, it's blah. Okay, interacting with Kubernetes is all about API, REST API, because the controller really needs to know if your system is healthy, started, and if everything is okay. So inside your container, you need to have what we call pod. You need to have what we call probes, so readiness probes and a liveness probe, just to say, okay, the component is just started and component is ready to get some requests. And there are some bootstrapping and loading time. And for Cassandra, it's about 20 seconds. So Cassandra itself is not enough. And so we implemented what we call a sidecar, which is another container running in the same pod, exposing a REST API to everyone just to see, okay, this is how my Cassandra nodes behave and what I can get from it. Yeah, and again, it's open source. Here is a link, and you can use it in your own Kubernetes cluster, even you don't use any Cass operator at all. Okay, moving on. Okay, so we explained Cassandra in Docker. Yeah, that's not what we want to do. It's a single node cluster on local dev, and that's it. We did also Docker Compose, and not enough. We need to orchestrate our containers. Then we introduce Cassandra in Kubernetes. Yeah, but the default resources in Kubernetes are not enough, so you need an operator. And with the operator, you're good to go. Now you can start and work with, with the Cassandra cluster. But now I do have a question for you. Okay. On your Kubernetes cluster, you do have your Cassandra system running. How do you monitor your system? How do you backup? How do you do the maintenance? How do you plug application on top of these containers? Well, to answer all these questions and make that as easy as possible, we implemented Cassandra, K-TES, so K-A-S for Kubernetes, Sandra for Cassandra. And in there, if you go to next slide, David, you will see that at the heart of this distribution, so Cassandra.io, again, open source, you will find Cassandra and the Cass operator at the heart, but also extra pods to do Reaper with Cassandra Reaper, open source as well, created by the last pickle company, which has joined DataStax now. Cassandra Medusa to do the backup, same principle, and even more, some tools to connect Cassandra to Grafana and Prometheus, which are monitoring tools. Okay, next. And now instead of defining YAML file for every single resources, so remember already with a single YAML provided to the operator, our custom resource definition, we were able to create tons of resources on Cassandra. Remember on Kubernetes. Remember all these pods and all the definition. with Helm, it's even simpler. So I'm Java developer. I like to call Helm like Maven for Kubernetes / Docker, or it's like npm or pip. Pip install, npm install, Maven install. Helm is the same. You do have some recipe with ready to go manifest. So manifest is huge YAML where you define all the resources you want to create in Kubernetes. And now with Helm, you can simply say Helm install Cassandra. And this guy will define all the resources, install the operator. And from that, you can also say, okay, now Helm, start me an instance of Cassandra, and boom, you do have a lot of pods and resources created for you. The idea is to make that very, very easy.
And I should add too that the Grafana and Prometheus implementations here, they're not just basic Grafana and Prometheus with nothing else added, right? Especially in the Grafana end, it's already set with all sorts of metrics and dashboards and charts that are relevant to Cassandra, right? So you're getting all sorts of knowledge that's already baked into that. And for anybody who's ever done that before, it's not too hard to hook up like Prometheus and Grafana. And the Cassandra has the plumbing for all of that. But it's it's something else that you need to go off and configure on your own, where here it's being all pre-baked and pre-configured per Cassandra node for you with all of those metrics and stuff. Again, relevant metrics, ones that you care about when you're actually running real Cassandra clusters. So there is a ton of knowledge from the community and the people who do this that is actually baked into this stack that's actually really important.
True. Okay, so let's see. Next slide. All the features for Cassandra, I told you already what it looks like. Next. Okay, so this is the project, cassandra.io, and this is where you can find the source code. And now, I would like to show you what it looked like, at least. And so I will try to share my screen again.
We're gonna do this again. All right, let me go back.
I'll try. So I have,
Are you
shut
ready?
down everything on so let me sharing my screen now.
All right.
Start sharing. Okay. And tell me if I'm okay.
All right, it's still, I think I see it. All right, we see your screen this time. Woohoo!
Oh, so cool.
Yay!
Okay, so everything that I'm showing you is part of GitHub. So the link github.com/datastax academy/KubeCon 2020, because Cassandra was announced at KubeCon 2020. Here you do have the slides. Again, we did not lie to you. Mm-hmm. And here is all instruction and command to use one after the other to make the demo running. So having a Cassandra cluster running and Prometheus, Grafana instances, and see what's happening. So you can either run these locally or use cloud-based environment. And so those cloud-based environment will be given to you if you use Alex. If you send an email to Alex Foloshnef, he provides his email, or Jack Fryer, or use the link provided here, and we will send instances to people once a day, and those instances will be available 24 hours. Or you can work locally. And if you do locally, you need at least 4 cores, 8 GB of RAM, and to install locally, here we do have setup local. Okay, so to work locally, you need a couple of tools. So you need Docker, what a surprise. You need a way to start Kubernetes on a laptop, multiple tools available. You may already have heard about Minikube or Kind. Here we provide you the instruction to run with Kind. And so having the small Kubernetes cluster on your laptop, you use the same command as set here. Now it can be slow because each time you need to pull, meaning you download all the images. Okay, and doing that in 2 hours was simply too short. So what I did, I do have my instance on the cloud, okay? And I do have the same YAML as in the repo over here, okay? And what I did, I simply first execute the command. So I do have my so when you get the instance, this is a web page we provide you, like kind of a home page for you. So if I go to Cassandra, my home page, this is what it looks like, and all the link to start tools are already provided. So you can use either the SSH console, but hey, I like to use my own SSH, and it's better because I can make things bigger on screen. So what I did, I simply use SSH, the SSH command to connect to the instance. SSH EC2 user at the URL provided, and I changed the password for my demo. Okay, so I'm the only one able to run to this IP. Don't try to hack my box. Okay, so first what you do, you tell Helm, remember the Maven npm pip install guy, to say, oh, you will need to download images from this helm.cassandra.io. So add this URL to your repo. Then you update the repo. So now you downloaded all the image. Then all these components need to talk to each other. By default, all the network, all the ports are closed for security reasons. And so when you want your pods to interact one to each other, you can simply open just a port with what we call a node port, but you can also open the port to outside of the Kubernetes cluster. And to do so, you are using yet another set of resources in the Kubernetes world, namely services and ingress. And so traffic, just one of the implementation to this port opening. So what you do, you add the repo and you update the repo. So now you update, okay, as usual. And now you will you will install traffic providing all these settings. So if I go to the settings, so traffic.settings, it's easier to look at this file on GitHub. So traffic values. What I simply say, and I say, okay, I will have multiple namespace and pods. What I would like to do is for traffic, I want you to expose this port. For service name pod, I do want to expose this guy, and the guy to expose this guy, okay? And doing that, in your menu, you can immediately start interacting with traffic. And now you do have all the rules and routing rules that has been set. So when you invoke the cloud instance we provided you using this URL, it will be routed to the proper pod. Okay. Okay, moving on. This is traffic. Then when we do have traffic, we simply say, oh, Helm install Cassandra tools, Cassandra. That's it. Now Helm will be ready to accept any command to start Helm. So namely, Helm install Cassandra cluster A using Cassandra cluster. And we can set some extra parameter, enable traffic, of course, and provide some configuration keys. So namely the address of your Linux box. We cannot know by advance what would be the IP of your Linux box. So we simply define some address environment variables, and those are simply mapped. And all these commands, I done that on my Linux box. And so if I now kubectl get pods and make that maybe smaller, like that, you see that even simply by doing kubectl get pods, this is all the pods, everything that has been started already for me. So here you do have kubectl DC default STS. Remember, this is our stateful set for our data center named DC1. And not only Cassandra using Cass operator, here is this guy, Cass operator. You also have some tools like Reaper for doing some not compaction, but read Reaper administration task, and also some Prometheus Grafana. So let's see if I keep going. So let's see. Yeah, it's pretty simple. Let's not go through all the steps. But what you will have is first you will have Prometheus. So Prometheus is a time series database, something that will listen to metrics coming from multiple systems, have some what we call service monitor to pull the metrics from external system. So here we do have an endpoint. So a Prometheus service monitor will pull the Cassandra cluster running inside Kubernetes and extract all these keys. So Cassandra, DC1, endpoint, Prometheus, and then it will be available in Prometheus. So maybe I can have something like that. And here I do have some events coming from Cassandra storing their time series database. But like that, yeah, it's not really happening. So working with Prometheus, there are some web UI named Grafana. You will plug Grafana to Prometheus using what we call a data source. So let me see, data source. And again, just help install Cassandra. Everything is set up for you. All these interconnection between Grafana and Prometheus and the Cassandra cluster is done for you. So here is our data source. Okay, we will use this data source to create dashboards. And so again, when you install Cassandra, you do have 3 dashboards available. One is, okay, what are the system metrics in my cluster? Okay, is it busy or not? What is the metrics? MEM, RAM, CPU, network traffic. Okay. Of course, you can use your own Prometheus, okay, your own Prometheus Grafana stack. You simply have to import the dashboard we gave you and the service monitor just to push the data to your own Grafana. So this is one dashboard, but not the only one. I do have Cassandra overview. So now I do have read throughput, write throughput, slow request, status of the node, the status history. So here I'm running a single node, but I could simply say Helm scale to 3 nodes, and I will see that it's scale, but it will take a minute or 2. So let's move on over here. And last dashboard available here is, no, I don't want to save my dashboard. Yeah, I don't know where I click, is what we call the Cassandra condense. And this is, again, some coordinator. What about the P95 latencies, namespace, more data related to the Cassandra JVM and Cassandra way to work, and not only some metrics regarding the environment. So again, that would be your homework. So go over here, do the exercise either on your laptop or using an instance we will provide you if you fill the form.
And something just to belabor the point too, I can't help myself with it, because watching all of this capability kind of grow over the last so many years, but coming from in the history of my own career and stuff of doing a lot of these things before Kubernetes, before the operators, before Cassandra and such. Like, imagine how many folks between the metrics, the configuration, creating the dashboards, hooking up the plumbing, managing the cluster, all that stuff that at some point someone or a team of people were doing right, for your organization or whatever, and that might even be for a single website or a database or something like that, that all of that is being encapsulated into this setup for you, right? Just what Cedric has just been showing you, just alone. I mean, again, hooking up Prometheus and Grafana, it's not that hard, but there's enough little configuration parameters, enough knobs, getting all of the knowledge that's been put into those graphs, hooking up Reaper, hooking up all the other management tools. That takes work, right? That takes actually a lot of work, and it's all being done for you here. So it's cool. It's for free, right? You don't have to pay for this thing. You just go get it. You do it. So I can't belabor that enough, because I feel like coming from an ops background and having to do a lot of the stuff manually, and then seeing this work all being done is just like, oh. So
yeah. You see that we add a compaction because this guy is running for multiple hours already, and immediately you see my latency, some jump here and there. But with that, I'm done with the small demo, and I guess it will be time for you to override.
If you take a look at the DataStax Academy organization, I will drop that down. Here you go. You'll notice in here, there is BattleStax, the one I was just talking about, Workshop, Spring Data Cassandra, Spring Reactive, right? Those are the ones that Cedric was talking about. All of our workshops are self-service. They're meant so you can actually work through them on your own. And most of these have the accompanying videos that are on the YouTube channel. So again, make sure you go and subscribe. And with that, Cedric, I think that's it, unless you have anything else.
No, let's wrap up. Remind you all the hackathon. So tomorrow we will do another time the same session, still live, still with you, still interacting with you. So regarding Kubernetes, and also tomorrow, same time as today, we would have asked me anything question regarding the hackathon. So if you are actually started on the hackathon, come join us live here, and we will answer your question regarding the hackathon.
Awesome. Well, with that, thank you, Cedric. Thank you, everybody. And we will see you next time. Take care. Bye-bye.
Take care.
And as always, don't forget to click that subscribe button and ring that bell to get notifications for all of our future upcoming workshops.
Imagine a being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats.